See. But here we go. Because right now I only have like 3 people turn something in. So I'll cancel it if I don't get more by the end of the day. Huh? You have one? Okay. I'll get it from you a little bit later. But here we go. Today we're going to learn what a composite integral function is and how to find its derivative. So we're going to talk about something called a composite integral function. You guys already know what an integral function is. Composite means more than one piece, right? Composite, it's composed of things. So you have a composite integral function of multiple pieces. And then we're going to learn how to find its derivative, okay? Now, we already know how to find the derivative of a normal integral function. Like if I told you guys I have this, what is the derivative? It's f of x. That's nice and simple. But this is not a composite integral function. A composite integral function is where they start doing weird stuff like this. It's where your limits are both changing. Okay, so you have a function whose the end point and the beginning point are altering as you go. So we're going to look at those, and we'll also be able to see hopefully what they represent and mean. All right, so let's go ahead and begin here. So I already shared that with you. Recall the second fundamental theorem of calculus. That's the derivative of an integral function. What's required for that is you have just an x up here and a number down here. If that's the case, then the derivative is just the integrand, but with an x instead of a t, right? But now we're going to talk about composite integral functions. All right. So go ahead and write down example 1 here, please. Composite integral function here, and I'm being asked to find its derivative. Okay. Now, first of all, if we didn't have these funky, weird things here, let's just ignore that for a minute, and let's write this up on the side really quick on our notes. If I didn't have that, then what would f prime be equal to? It would be ln of x, right? So that, and I want you to have that, so that's going to come in handy later to recognize that. So if those weird funky limits weren't there, then basically the derivative would just be ln of x. All right. So here we go. Now we're going to handle this problem mostly symbolically, which means we're not going to really do actual calculus to integrate, but we're going to use the ideas of calculus. So you'll see what I mean here. So let's go ahead and integrate ln. Now, we never learned an integral for ln, just so you know. There is one, but we never learned it. It's just not something you're required to know in Calc AB. But there is an integral for ln. But we're not going to use it, okay? We're going to go ahead and integrate this. So if f prime equals ln of x, then the integral of ln of x is f of x. So here's what we're going to do. We're going to use the fundamental theorem of calculus here. The integral of ln is f of x. You guys agree? We're going to go with that for right now. So if I integrate this, I'm going to have f of blank minus f of blank. And what goes in the first blank? Good. And what goes in the second blank? 3x. Because if I integrate ln, I don't know what that integral is, because we never learned it. But we're going to call it big F of x, because that's what according to this problem, the integral of ln is big F. All right. But using the fundamental theorem of calculus, we plug the first one in the first and the bottom one on the second one there, right? Now, they're asking us to find what? They're asking us to find f prime of x, okay? So f prime of x, if I want to find the derivative of that, since f of x is equal to this, which is equal to this, don't you guys agree if I want to find the derivative of f, I can just find the derivative of this instead? Okay, now to do that, I need to do the chain rule, okay? So what's the outside function here? It's f. We don't know what it is, but we're calling it f. So the outside function is f. So we do the derivative of the outside, don't change the inside, multiplied by what? which is what? 2x. Okay, let's repeat that here. Derivative of the outside multiplied by the derivative of the inside, which is 3. Okay, so now that I've done that, I didn't know what the integral of ln was, so I just put big F, okay, to represent this unknown integral of ln. And then I found the derivative of that, right? But now, after I take the derivative, I don't have big F anymore. What do I have? I have big F prime. I do know the function for big F prime. What is F prime equal to? It's ln. It's up there, right? So check this out. I'm going to write this instead. Instead of F prime of x squared, I'm going to write ln of x squared. And instead of F prime of 3x, I'm going to write ln of 3x. There's my answer. Kind of weird and awkward, but there it is. That's the idea. So that's what that derivative would be. Okay? So let's kind of review here. Now, there's kind of a shortcut here in case you guys aren't seeing it, right? We don't have to do all this weird, complicated thought. This function here, you're going to put that into it, right? And you're going to multiply it by the derivative of the inside. Same thing over here. You're going to take the ln again and put this into it and multiply it by its derivative, but with a minus in between. But really all we're doing is the fundamental theorem of calculus. Okay? So can I clear that? All right, kind of awkward, but there it is. The reason it's awkward is because to me it's like, well, we're working with a mystery function that we don't know what it is. So we're just representing it with a letter. But the reason why that's okay is because after you take the derivative, it just goes away anyway. So it's like a ghost thing. It's like a placeholder for something that we're going to get to later. All right. I don't know if that makes sense, but there you go. Let's do a guided practice. Ready? So go ahead and write down this problem real quick. All right. So my first question is going to go to Orion. Orion. Hook it up. All right. So, Orion, I'm being asked to find G prime. So, Orion, if I didn't have these weird, funky looking things here, what would G prime be? No. But good guess. Let me ask somebody else. You're kind of looking in the right place. No, Angie. I'm missing a lot of people. Andrew. Yep. If I didn't have these weird, funky limits here, what would G prime be?
G prime would be equal to f of x.
Not what I'm looking for, but you might be right. But there's no f up here. They didn't give me anything about an f. I don't know about John. John, are you tracking with us? John is. Are you tracking with us? Can you answer that question? What would G prime of x be? No. Okay, I'll try one more. Let me try grading. Go ahead, grading. It's sine of x. It's the integrand. There we go. So you want to remember that. Keep in mind that G prime is going to be sine of x. Okay? So basically the derivative of this is whatever's in there. Okay? Now, why isn't it negative cosine like Orion suggested? Because there's an integral here. And when you take the derivative of an integral, they just cancel each other out. So you're just left with that piece there, right? So you're not going to actually take the derivative of sine because the derivative is neutralized by the integral. They kill each other. So you're just left with the function there.
So like because of the limits,
the limits are going to is a game changer. But if you ignore the limits and just kind of think of this as a normal integral right now, and you take the derivative of g, the derivative is going to cancel the integral, and you're just left with sine. So, and you know, we learned this on the second fundamental theorem of calculus, right? This is what you said.
Oh, so that.
So g prime would be f of x, right? Well, in this case, we don't have f of x though. What do we have? Sine x.
Okay.
So it's the same rule.
So that squiggly line, I know that sounds silly. That giant s, that's an integral, right?
That is an integral.
Okay.
Yes.
understand the concept of it. I just didn't really think of it like.
Yep, that's an integral. All right, so we got through that hurdle there. Let's continue our process of getting through this problem here. Next question is going to go to Miss Zarina. So Zarina, my question is, what am I going to put over here? Be careful with your letters, by the way, because it's not the same as my problem was. The letters are different. You're doing too much. I just want to know, you might be giving me the final answer, which is fine. I don't want the final answer. I want you to kind of go through the same steps I did. So what would I write here? Just little, in this case, it was little g. Because on mine, what did I have over there? It was a big F, right? So little g. And so Zarina, I'm gonna come at you again here, because you're probably doing it right. I just want to make sure you're tracking, like following the stuff with me. So what goes in here? Uh-huh. Okay. Now, Thea is not with us, but I shall ask Savannah. Here she is. Savannah, let's take the derivative of this thing. So, it's a chain rule. So, Savannah, if I wanted to take the derivative of this, what would the answer be? Not sure? Okay. Vamos. Amanda Estrada, how about yourself? What's the derivative of this? Close. When you take the derivative of e to the x, it's not just e, it's e to the x. Good. So it's a chain rule. The derivative of the outside is g prime of e to the x. The derivative of the inside is e to the x. The derivative of e is just e, right? E to the x. Next one, James. Well, maybe instead of coming to James, I want to come back to Savannah. You want to try this one now, Savannah? Uh-huh. Close. We're missing one little thing. Prime. That's the derivative of the outside. Then we have the derivative of the inside. Okay, now, Vivian's not with us. But I am going to be asking James. James, I want to replace g prime now with something. What am I going to replace g prime with?
Sine of it.
You got it. Because g prime equals sine of x. We said that at the very beginning, right? So I'm going to replace g prime with sine of x. So instead of g prime of e to the x, it's going to be sine of e to the x minus there you go. So that's the derivative of it. Okay, so we had a few hang-ups here. So I want to review them with you guys. If you ignore these and just think of it as a regular interval, what's the derivative of g? It's just what's in there, right? The next thing that we had a little bit of a hang-up on was how do you take the derivative of this? It's a chain rule. So we take the derivative of this symbolically. It's g prime of e to the x. We don't know what g is, so we just put g prime of e to the x. But you multiply it by the derivative of the inside, which you can actually find the derivative of. It's e to the x. And so there's that. Okay? So let's see how you guys do if I throw one here at you. There you go. So why don't you guys try this problem here? And Dustin, when I was in, his name was Dustin, but anyway, he was talking about he never liked really. He was a smart guy himself, but he wasn't like into school. So those smart people are really weird. He was talking about how one time he was talking to a college professor, and the college professor, really smart guy, and he's sitting there just having a normal conversation with him. He takes off his glasses and starts cleaning his glasses with a rag, right? While he's talking to him. But what the rag was it was the end of his shirt as it was coming through the zipper of his pants. It's like, he goes, that's what a college education gives you. Weird people. Okay. All right. Now if you get too weird, those really smart people. You guys ever notice like super smart people a little weird? I had one college for love him. Amazingly intelligent man. He was actually at ABC. Some of you guys might know him. His name's Dr. Seeger. Has anyone heard Dr. Seeger? He retired recently, so. Well, after every sentence he would say, he would go, eh. So you're going to take the derivative, okay? And then when he would erase the board, I don't know what his deal was, but he was in a rush, so he would hop. It's like, the guy was a freaking genius, but he was nuts. It was really interesting. So, when you guys go to college, you're going to find that you're going to get some weird people teaching you probably. So it's okay. It's okay. They're the ones that come up with those formulas and stuff that change the world. They're just a little different. Okay. So here we go. Teo's not with us, but I'm going to... John? Matthew's with me. So, Matthew, you could just tell me the final answer if you like. Go ahead.
3x squared times x to the 1/3, or x cubed, or cube root of x, minus
X cubed. There's our answer. Now, let's take a look at what an integral function is. So first of all, what is an integral, you guys? What does an integral tell us? It tells us area under the curve. But here's what's interesting. Look at your limits. Your limits are changing. So not just your top limit, because the way we were thinking about this before was we were thinking about a curve, right? And if I have an integral function, right? So my area starts at 0, and as x gets bigger, the area grows, right? But what's going on here is both of your limits are changing, and one of your limits is changing like more. So for instance, no. All right. So which one of these numbers changes faster, x cubed or 2x? X cubed. So that means that your top limit, as x is getting bigger, is shooting off really quick to the right. This guy's changing also. As x changes, it's also going just slower. So what we have is something that looks something like this. I can't do it, but this hand should be going faster than that one. But you guys got the idea? So I want to show you guys a picture here to represent what we're actually looking at here. And then we're going to talk about what that represents, because it means something. Putting my Google information up for all the world to see. That's good. Okay, let's see. Here we go. So look at what we have here, guys. I've got a function. The function is the red line. It's sine of 2x plus 2 is what that red line is. But do you guys see the limits, the upper limit and the right-hand limit? They're changing at different rates and they're moving at their own rate. But as those limits are changing, the area under the curve is changing. So the function's the red line. The integral represents area under the curve. So let me ask you guys this. Today what we're doing is we're finding the derivative of something like this. What does the derivative tell you about this graph? How fast the area is changing. At what rate is that area changing? As you guys can see, at this particular point in time, the area is increasing, but here it's decreasing until boom, at that moment the area it's reaching 0. So the area is constantly changing because those limits are changing. And so that's what a composite integral function is, where you have an integral function where both limits are moving around, you have a changing area. Now, unfortunately, I can't tell you why they would ever use something like this. I don't have the answer. But that's what we're looking at, and that's what it represents. So when we're finding the derivative, you're finding what is the rate of change of the area at that point in time. You have a question? Oh, I thought you had your hand up. Okay. So let's do another example. This one's a little bit different, and you'll see why in a second, but go ahead and write it down. Whew. It is. It's very good. Say it. Say it. No. Okay, let's try this again. You guys ready? I'm going to come back at Orion because I love Orion.
Yes, sir.
He's my friend. We hang out and stuff.
Okay, that is not. That is not okay.
Orion.
You are a grown man.
Orion. What is h prime of x?
X squared plus 2x.
There you go. Nice. So if we just ignore these for a minute, we're not thinking of this as a definite integral, just an indefinite integral. The derivative of h would just be the integrand there, right? All right, so keep that in mind. Okay, so here we go. I bet you guys would probably already understand how to do this without doing all the steps. I'm still going to use my steps, though, but I'll show you. You guys probably know how to do it anyway, so it's fine. But anyway, so I'm going to write, what am I going to write here, Michael? What does this equal, first of all, according to the fundamental theorem of calculus? Yeah, just keep going. That's what you said? Okay, I agree with that. Looks good. Okay. Next one I'm going to ask Graydon. What do I do now? Good? Good. So he's right. It's a chain rule. Now I'm going to ask someone to tell me what it actually equals, though. So Neha's here. Neha, tell me what to write. Did you say minus? It's just times, right? Times h prime of sine x. And then minus. Good. Okay, so here's the first thing I want you guys to notice. When you have a constant, it doesn't matter what h prime is. You're multiplying it by 0. What's it going to be? It's gone. So anytime you have a constant on the bottom, that piece is just gone. When you take a derivative, it's just going to go away. So we don't really need it. So we really just need to focus on that first part there. So now we have the next part. Now this next part is the hardest part, okay? Because it's a little bit different. Every other problem we've done, we just take what's on the inside right and we plug in the number there instead of the function, but it's a little bit weird. So let me show you why this one's a little bit weird, okay? I'm not going to call on somebody for this one because it's a little bit weird. But what did we say? What did we say that h prime of x was at the very beginning? It's x squared plus 2x. Do you guys see how there's 2 x's there this time? So whatever's inside these parentheses needs to go in both spots. So it's going to look like this. Plus 2x. What's going in the parentheses? Sine x. Okay, so it's x squared plus 2x, and we're replacing the x with sine x. Now, if this piece over here hadn't canceled out, we would have done the same thing over there. You have to write x squared plus 2x with blanks and put the 7 in the blanks, but we didn't have to because it canceled out. So this one kind of just demonstrated two things. It's just an extra example to kind of help you guys kind of see a weird situation. Constants go away, right? And then also, if you have a polynomial or something with more than one x in there, when you get to that last step, you have to plug the input into both spots, okay? Other than that, it's the same. Whether or not you wanted to distribute this through or not is up to you. But what this represents is a polynomial, right? And the right endpoint is changing by a function of sine x, which, by the way, what that means is sine goes like this, doesn't it? It goes up and down. So you have this polynomial. It looks like a parabola, right? There's my function, the parabola. The right endpoint is changing by sine x, which means it's bouncing back and forth between 1 and -1. So I don't know what this parabola looks like, but I'll draw it like this. So here's 1, here's -1. My right endpoint is going back and forth repeatedly, but my left endpoint, I guess if you want to call it that, is stuck at 7. So you have an area that starts like over here, and it's just constantly shifting back and forth between those two numbers because of the sign. And the area has a rate of change as it's doing that. Okay? And do you guys see now why this one doesn't matter? It's just sitting there the whole time. So when the area is changing, this has no effect on the rate of change. The sign of 7 there, or the 7 value, it's fixed. It doesn't move. So that's why it just goes away when you find the rate of change. What has all the power is this guy. That's what's changing the area back and forth, back and forth. All right. So that is an integral function there. Why don't you guys try this one? See what you get. Once again, just has a few weird little twists in it. Matter of fact, I think I'll add some more little twists to it because it's just too easy.
What?
There. All right. Go ahead and do that and find for me that derivative. No. If you can jump right to the end, I'm okay with that. Totally. Totally okay with you jumping right to the answer. It represents, let's see what you have there. So, here we go. So, as you guys are kind of starting to see here, there's just pretty much a formula that we're using repeatedly. You don't need to go through all the steps that I'm going. So I'm gonna show you guys a formulaic way to do this. Okay. So here's the formulaic way to approach this problem. Basically, you're going to be writing this, but everywhere where you have an x, you're going to have some blanks, right? And in those blanks goes the numbers, the limits, right? Where did it go? I think it was this one. Okay. And then you put that in brackets and you multiply it by the derivative of that inside, which is just 0. But so in this case, everything goes away, right? Then you have then you have minus, and you just do the same thing, but with the other limit. So it's going to be 1 over blank to the 4th plus 5 blank. And this time I'm plugging in 3x squared. And don't forget to multiply it by the derivative of 3x squared, which is 6x. So this is gone. We can just ignore this. So that's what your guys' answer should really be left to be, right? Now, a lot of you guys left, that's fine. But I doubt they would leave it like that in a multiple choice test. And I've never seen something like this on an FRQ. So this is really, I have seen them on multiple choices, though. So this is a more multiple choice thing. So you want to know how to simplify it if you can, right? So first thing we would do is this. What's that going to give me? 81x to the 8.
Yeah. Oh, it's 6x. 6.
No. So we're raising this to the 4th power, right? So 3 to the 4th power is 81. And then x squared to the 4th power is x to the 4th. So that's what that would be, right?
Wait, isn't it to the 8? Yeah, that's what I said. Yeah.
Oh, yeah.
Yeah, that's what I was saying.
Sorry. Don't let me be the victim of your capital crime.
I was about to say it like that.
All right. Now, how about this one? This is easy, right? This is 15.
Well, I am done, but it's not 15.
Yeah, it is.
Obviously 20.
15? 5 times 3?
Yes, it's a joke. Jesus Christ.
All right. Sorry, I don't have it. You'll be here one day, don't worry. Remember? Okay. The next thing we're going to do is we're going to multiply this in.
Remember what you mean.
So we have this. You've blocked it out of your memory, huh? And then negative 6 times 15 is 90, right? And it's going to be x cubed now. Is that right? Okay. And then last step is we can reduce this. This x causes the bottom to become 7. And then 3 goes into both of these, which is 2 over 27. So that the cleanest answer you guys could write would be this. I know, but on a multiple choice, that's probably the answer they'd have. I don't think they'd go the extra mile and make a common denominator, but they technically could. I doubt they would.
How did you get 27x7?
I reduced the top and bottom by 3. So 6 divided by 3 is 2, and 81 divided by 3 is 27.
Oh, there wasn't. Oh, thank you.
We good?
You didn't have to do all that.
You don't. Well,
He's just trying to make you guys suffer.
yeah, that's true. I mean, I have to sit up here and act like I'm doing something, so I just make stuff up.
You're terrible.
I know. So we have a formula. So if you guys want to write down this formula, you could put it on a flashcard. Now, I didn't want to teach the formula up front because, honestly, there's no way you're probably going to remember this formula unless you're one of those people who are going through your flashcards once a week like I told you. You're all doing that, right? Your head's going the wrong way. Try again. You're doing that every week, right? It's broken. Here, you work on your hinge. It goes this way. All right. So you know, if you're going to take the time to really be diligent about memorizing things, and the formula is nice, it does make things faster. But you guys notice the way that I taught it was figuring it out. What's the integral is? I don't know. So we're just going to dig out. Now we take the derivative of that chain rule. So really, to me in mathematics, memorizing formulas is not helpful. I want you to be able to figure things out as you go, right? Because memorization is very taxing. It takes a lot of time, and it doesn't last. So, but I will give you the formula anyway. So here's the formula. You guys naturally saw the formulas in your head too because you understood the process, and so that's what I'm really going for here. But r prime of x, here's your formula. Ready? It's f of h of x, right? Multiplied by h prime of x. So f prime of the top multiplied by the derivative of the top minus f prime of g of x times g prime of x. There's the formula. So you can use it if you want to, but, you know, at most you're going to see maybe 1 or 2 questions like this on your AP exam, not very many, honestly. They're multiple choice. So spending all this time to commit that to memory is probably not going to be as effective as actually just understanding how we got there. So you can be a little bit more flexible and figure things out. But there you have it. So what time are we looking at right now? 9:29. So I'm going to do one more problem. You don't have to write it down if you don't want to, but you can. I just want to demonstrate to you guys how to use the formula, but I don't remember this formula. You know, I've taken calculus multiple times. I've taught it 3 years in a row, and if you guys asked me this formula 2 weeks ago, I would not have been able to tell you. So, but I can figure it out, and that's what I want to encourage you guys to be able to do, because I can't remember stuff like this. Hello. Oh, she's not here today. Do you want to keep it, or should I keep it?
You can keep it and give it to them.
Now, I want to see these pictures. I noticed that they're arranged in such a way I can't see. Is this a violation of the federal code of looking at private mail?
It might be. They're from that athletic. Leave her alone.
All right. So I'm going to demonstrate how to use the formula. Because after you do a couple, you kind of just know it already. What if you want to?
Wait, so what we're doing again?
I'm just doing another one, but with the formula this time instead of figuring it out, right? And so here's the formula. The formula is you take, hold on. Let me back up. I just realized, I wrote the formula down wrong. I just realized that. Don't make that sound. All right. Here we go. Can you guys make a correction here? Does anybody know what the error is I made? I'll give you some points if you can find it.
You found what?
Huh?
Oh,
No, that's not the error. No.
Oh, wait, okay. Yeah.
Try.
Parentheses around the HX.
I'll give you a point for that, but that's not the one I was thinking of.
Oh, wait.
It's an actual big conceptual problem. Like it's wrong.
We also did forget around
We'll figure it out.
Sure.
I'm not gonna lie. parentheses on G convex?
So I'm saying it for the sake of the video here. My error is that the F's should not have had a prime on them. So make your corrections there if you need to. Anyway, so coming back to this then, I'll work this out really quick. So here's how the formula makes things go faster if you want to take time to memorize it. So you take your original function, x squared, you put that in there, and you put its derivative outside of it. Minus, repeat, original function, you're going to put this inside of it, and the derivative of that on the outside, boom, bada bing, bada boom. So you can use the formula that way if you want to. So, but, like I say, it's faster, but not easy to memorize that formula. Do as you will, children. All right, so we're good. This was our last unit. Like I said, I'm going to try to make a study guide. I'm going to try to do a video. I would like to do a test on Monday. I'm pretty swamped. There's a chance we won't. So we'll see.
Should we simplify it or no?
Say what now?
Should we simplify it or only repeat?
I'm going to not simplify it, but you could. But you could, yeah. Because we're just out of time.
A tug of war. A tuggy war.
They have domination on shit.
Dude, that's a tug of war.
Domination on shit so much. I played that. It was on the.
Domination's like my favorite game most.